Now the main concept you need to remember is this. What you need to know in this case is product principle. Oh, one second. Now, in the product principle, what do we do is, if there are m different ways of performing an operation, and for each of these there are n different ways of performing a second independent operation, then there are m into n ways of doing each of the successive operations in succession. What does that mean? Suppose from A to B, to go from place A to place B, there are 3 routes. And from B to C, there are 2 routes. So how many ways can you go from A to C via B?
A to C is 2 only.
How many routes are from A to B? How many routes are there? 3. 1, 2, 3.
Oh, 3 routes.
From B to C, there are how many routes? 2. So 3 2s are 6. So that's what thing is. So one thing can be done in n ways, and after that is done, other can be done in n ways.
Okay, but they have to be interconnected. So, operation is independent. The second thing is an independent operation.
Independent operation is a different road altogether from B to C.
But they are both connected.
There will be some sort of connection, no?
Okay.
Otherwise, you can't have 2.
Okay, got it.
N factorial. N factorial is defined as n factorial n into n minus 1 into n minus 2 up to 1.
What up to 1, sir?
Definition. Defined. Defined means what? You can't challenge it.
Oh.
So 3 factorial 3 into 2 into 1. 3 2s are 6. 5 factorial is what?
5 into 4 into 3 into 2.
Follow? Whatever it is. And is read as n factorial.
Okay.
0 factorial is defined to be 1. N factorial is number of ways, now this you have to learn this up. Number of ways of arranging n objects in order.
In order, okay.
So if I tell you, in how many ways can you arrange the alphabets of the THE? So what is the 3 factorial? 6 ways.
Oh, okay. And you restrict the factorial. As long as you're repeating.
So that means it will be T, E, H.
Yeah, H, E, T.
H, E, T, H, T, E. Correct? Then E, T, H, E, H, T. See, you will automatically add 6 ways.
Right.
Arranging amongst themselves.
Okay, got it.
If n is greater than r.
R will?
If n is greater than r, there are 2 variables n and r.
Okay.
If n is greater than r, the number of ways of arranging r out of n objects is called the number of permutations.
Okay.
Of n taken r at a time. So what does that mean?
So this is when the order matters or order doesn't matter?
Order matters.
Order matters.
So if there are 3 seats and there are 4 people.
For P3.
Yeah, for P3 will give you the number of permutation. Permutation is arranged.
Okay.
When you arrange, order is important.
Okay. And combination, it does the order.
Yeah, and the formula is n factorial, r factorial, n minus r factorial. Sorry.
So r factorial is for C, no?
Yeah, n factorial divided by n minus r factorial. A combination is selection of objects without regard of the arrangement.
Okay.
The number of combinations of n objects taken are at a time. Suppose there are 14. Suppose there are 14 players and you want to select, let's say, team of 8.
Okay.
So that's 14C8.
It doesn't matter which 8 you choose.
It doesn't matter which 8 you choose. The n factorial, r factorial, n minus r factorial.
These are these given in formula book?
Yes. So try this out without calculator. Okay, let me tell you a shortcut.
Okay.
Your 10C3 when you're doing.
That time you use the formula, right? N factorial over
Shortcut.
Oh, that also? Oh.
You do 10 into 9 into 8 upon 1 into 2 into 3.
Okay. So 90 times 3 so 720 upon 6.
2 4s are 8. So 120.
Oh, so you start with 10 and then how many ever terms, whatever your R is, you just take those many number of terms. And then from the bottom it starts with 1.
Like suppose if I give you 5C2.
So it becomes 5 into 4 over 1 into 2.
That's how much? 10.
20 over 2. 10.
You reduce it. Don't multiply and divide. reduce it. Then
okay.
This one you go down. N
minus 1 and minus 2 upon
Now look at this one. Which is the smallest factorial?
8 factorial.
So break it up everything into 8. 10 into 9 into 8 factorial.
Okay.
Minus 9 into 8 factorial. Plus 8 factorial.
We just factorize the 8 factorial.
Remove factorial. 90 minus 9 plus 1. That's how much?
82. Oh, same thing. You can't do anything for them.
You can't do anything for them. You can, but it's a big.
Would they say
if 5 men and 5 women are seated on a table, let's say, not circular. How many arrangements are possible if they alternate? So let the woman sit first.
Okay.
So 1, 2, 3, 4, 5. So that's 5 factorial.
Okay. Assuming we're sitting out, they're sitting next to each other, right? Okay.
Leaving one space in between.
Oh, they're leaving a space, okay.
Now, how many places will the men get?
They need 5 places.
1, 2, 3, 4, 5, 6.
Yeah. Yeah, they get 6 options.
But again, this won't help. There will be 2 possibilities. You start with women and start with men. So suppose if you say this is not available.
Which one? The one at the end?
Okay. So then this will be 5 factorial?
Yeah, so 5 times 5. 5 times 5.
Now suppose you make the women sit and you say this is, the men have to sit only on the crosses. So that will again be 5 factorial into 5 factorial?
Yeah.
So either this or this?
Yeah, they're the same thing, no?
2 into 5 factorial into 5 factorial is the answer. So how many consonants are there?
4. X. I'll say M, M, X.
Consonants M, 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 X. Vowels how many are there?
4 or 3. I, U,
A, I, U. Correct?
Yeah.
Now, the consonants have to appear next to each other.
Yeah.
So you put them together, you fix them together.
Okay.
That one group, and you treat this individually. A, I, U.
Okay. So you have 2 plus 4, so 4 factorial.
4 factorial. Into the consonants among themselves can be arranged in 4 factorial way.
Yeah, 4.
Divided by the repeated factorial.
Which is 3 factorial. Oh. So 4 factorial times 4.
So 4 factorial, 4 into 3 factorial, divided by 3 factorial, cancel out. And whatever answer you get.
4 factorial times 96.
All that is not important. You see, you want to focus on the concept or the calculations. I mean, you can 16 threes, you can just work it out again, whatever that is. That's not a point of discussion right now. A committee of 4 children is to be formed from a group of 8. The oldest 2 children cannot be chosen. Find the number of their committee can be chosen.
Okay. So first I have 8C4.
A committee of, but why that is asked?
Oh, we don't use. So I thought every time you see something like that, where you have a certain number of people and then you have to choose a certain number of people, you always use C or P, right? Or is that not the case?
Choose a C.
Okay. So this will be 8C4, right? Because so out of 8 kids, you have to choose 4.
But that's not the question.
You're saying find number of ways. So.
You're not understanding the question. A committee of 4 children is to be formed from a group of 8, but that's not the complete question. The 2 oldest children cannot both be chosen.
So one of them has to.
So when you say 8C4, you're including everything.
I can't do that.
I mean, you can do that, but that's not the question.
Yeah, and I can't even make it 6 because that's assuming that none of them are chosen.
None of them are chosen. Both cannot be chosen.
Okay. Does that mean none can be chosen?
Yeah.
Okay. So it can either be 7.
So see, oldest, youngest. If we choose the oldest,
okay.
If you choose the oldest, how many possibilities would be there?
So 6 factorial, right?
So see, you have oldest 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8.
Okay.
So one committee you will take where you will choose the oldest.
Okay.
You want a committee of 4. So now how many more you need?
Yeah, 3 more, correct.
You want a committee of 4. You've taken
you
oldest.
You have 1 already, so you need 3 more.
3 more. 3 more from which? How many?
Out of, if you have 8 minus
1,
6,
2,
6.
3, 4, 5, 6 out of 6. So 1 and 2, 6 C3.
Yeah. Why do we do 1 and 2, sir?
I just to show that I have.
Okay, but it's basically
1, there's only 1.
Okay.
Or else what you can do is 2C1.
Okay.
Either you choose the oldest or you tell
Yeah.
You can do like that. Or else you can do it separately.
Oh, but yeah. Either way, you're only going to have 6 left, and you have to choose any 3 out of those 6.
Or
you have 0.
Yes. Then how many will you choose?
7. Sorry, 4. You choose 4 out
Correct.
of 8.
6.
Out of 6, out of 6. So both of them.
No, both of them. So that's why.
So you add up all the possibilities. Those are the number of ways.
You can take oldest as a committee, youngest as a committee.
So number of ways can be either permutations or combinations. Just in one order.
Committee is combination. You're not arranging it.
Okay, it doesn't matter.
There's no question of combination. I mean, there's no question of permutation over here.
But so anytime they're asking us to find the number of ways of something, so it can be either, right? Unless it's specific to say like a
number of ways will always be there.
Huh.
You have to check whether you're choosing or whether you're arranging. It's clearly shown you're choosing. Number of ways is always the question.
So even though permutations is a question,
number of ways, yeah.
Okay.
I find a number of ways they are arranged. Right.
Got it. And that time you just know you have to use permutation.
Yeah.
Can there be combinations of both? Can there be a combination of both where you have to use
yeah. Many sums.
Calculate
We choose and then arrange. But permutation takes care of that actually.
Of combination as well.
When you choose and arrange, it's same as arranging. I mean, when you're choosing and arranging.
Right.
So when you do NPR,
when you divide by that R factorial.
Yeah. So when you do NPR, you're choose. So suppose you do 6P3. Out of 6, you're choosing 3 and arranging 3. Both is done when you permute.
You're arranging those 3 which you
chose. So you've chosen 3, no?
Yeah, and those 3 you have to arrange into. Okay. Got it. Okay.
Okay, so let me just for completion of this. So this is your 10P6 basically, correct? Because you are arranging. The key word is number of different ways they are seated. I'll tell you this is a standard procedure. Whenever you are arranging books on a shelf, it's permutation. Whenever people are sitting for a photograph or sitting, it's permutation.
Okay.
Because the order is important. Arranging words in a letter, permutation. Arranging numbers in a digit, permutation.
Right.
Forming a team, forming a committee.
Combination.
Simple.
Okay.
Rule of thumb.
So team wouldn't be permutation or you need say specific.
Then it becomes permutation. But it
unless you define that.
Now, there are how many seats?
10.
You want those 3 sisters together? Yes?
Yeah.
Now, 1.
Okay.
2. 3. 4. 5.
Yeah.
6.
Yeah.
7. So that would be 7. Correct? Into.
Okay.
They can be arranged among themselves in 3 factorials.
Okay.
Into. Once those 3 people are seated,
the other 3 people can sit anywhere.
Other 3 people can sit anywhere. If 3 girls are seated, if 3 sisters are seated, how many seats are vacant?
7.
7. And how many do you want to occupy?
Oh,